Hello everyone, we are going to look at the reaction of free radical substitution. For the synthesis of chloroalkanes. Okay, so the first step is called initiation. And this step involves the formation of the chlorine radical. So we have a chlorine molecule, and this is hit by UV light. It undergoes homolytic fission to produce two chlorine radicals. And we show the radical by placing this dot next to the chlorine. Now, what a radical actually is a species, so a free radical is a species with an unpaired electron. So that was step one, which was initiation. Second step is called propagation. Now, this is when the chlorine radical is going to meet an alkane. So, chlorine radical is going to meet an alkane molecule. And free radicals are highly reactive species, and what the radical will do, in order to stabilize itself, is going to take a hydrogen off this methane molecule. So now we're going to get HCl. That chlorine radical has stabilized, but now the methane molecule has become a methyl radical. And that's the first step of propagation. The second step of propagation is going to be the methyl radical is going to meet a new chlorine molecule. And again, radicals are highly reactive species. So it's going to take a chlorine from the chlorine molecule. It's going to take a chlorine atom. So we're going to get chloromethane plus a new chlorine radical. Now, this chlorine radical can in turn go and react again and again and again, which is why we call this a propagation. Now, the final step is the termination step. The termination step is just going to be when two radicals can combine to make a product, and it will terminate the entire process. I'm just going to pick the methyl radical and the chlorine radical to make chloromethane. And that has terminated the reaction.